Okay, good afternoon. Good afternoon. Welcome to our virtual K-State Research and Extension Pasture Management meeting. As you know, we are faced with a kind of a different situation here with the pandemic. So we switched a lot of our meetings to virtual. So we are glad that you could join us this afternoon. My name is Sandra Wick. I'm the crop production agent with the Post Rock Extension District. And so we are thankful that you could join us this afternoon. And please let us know if you're on, you must not be having any trouble. But if you know some of your friends or neighbors or whatever that's having any trouble, just call any of the extension offices and we should be able to help you out. So we have several other extension agents and extension districts that are also helping with this. So I'm going to turn it over to Alicia Bohr.
Thank you, Sandra. Our collaboration team for this meeting on pasture management is Justine Henderson. She is the livestock agent for the Central Kansas District. Myself, I am Alicia Bohr, and I am the agriculture agent, one of them for the Cottonwood District, and I am housed out of the Great Bend office. We have Clint Laughlin, the director and livestock agent for the Midway District. Brett Melton is the livestock agent for the River Valley District. And then Sandra Wick, who you've already met, is the crop production agent for the Post Rock District. We would also like to thank Arthur Selman, who is helping us put this on. He is the technical aspect for the agronomy department, and he has helped us mesh onto YouTube Live today. And then I'd also like to thank the two presenters that are willing to do this today, Keith Hermany and Walt Fick. So without further ado, we will let somebody introduce Walt.
Okay, and that somebody would be me. My name is Brett Melton, and I will be introducing Dr. Walter Fick today. He is a professor and extension range management specialist in the Department of Agronomy at Kansas State University, and he has responsibilities in teaching, research, and extension. His major areas of interest include invasive species, prescribed burning, and grazing management. And we will go ahead and move over and put Walter's slides up and let him take the reins.
Brett, while he's getting those up, can you let people know about questions in the chat box?
Yeah, absolutely. If you have any questions, you'll see the chat box up on to the right of your YouTube screen. If you're on a mobile device, it might be up to the bottom. But feel free to type those in as we go through today. Anything that comes to mind, you can ask Walt, and we'll get to those at the end of the presentation. So again, feel free to type them in as we go through the presentation.
Okay, well, thanks, Brett, for the introduction. I was asked to talk to you today about pasture management and weed control, so we'll get right into that. I'll start off with talking about some basic principles of grazing management, and then get into some brush and weed control, some specifics on certain species, and hopefully then we have time for any questions that you might have. Wanted to emphasize, of course, that Kansas is a range and pasture state, and this set of data would indicate, something over 15.5 million acres of what's called pasture land in this particular ag census. Most of that, I think, actually is rangeland, because I know there's an additional 2.5 million acres of tame forages, primarily in the eastern part of Kansas, smooth brome, tall fescue, and Bermuda grass. So a little bit about grazing management. Kind of animal is something that we might be able to select. Kansas is indeed a beef state, 6 million head of cattle, maybe 1.4 million or so head of beef cows. But there are other livestock out there that are grazing, including sheep and goats. One can talk about season of use, distribution of grazing, stocking rate, and then grazing system. and I'm not going to cover too much of those topics other than bring them to your attention. The key one of those that I would like to emphasize, however, is stalking rate. Stalking rate is the number of animals per unit area for a given period of time. And this is this long-term study that was done at Hayes. But as one increases that stalking rate, otherwise less acres per animal, you can see this blue line here that the performance on an individual basis, the gains on those livestock decline. However, as we increase that stalking rate, we look at the other line, we can actually increase the gain per acre, at least up to a point. And somewhere there in the middle, not necessarily where those two lines cross, but somewhere in this general area is usually what we consider a moderate stalking rate, at least for season-long grazing. And that has also been shown to be the most economical rate to use as well in these studies that have been done. A little bit on successful grazing management and knowing when buds are being formed, like I say, in our tall grasses, particularly our rhizomatous species. Those buds are often formed in the late season. But then, you need that bud or meristem for those plants to grow. But then we also want to be concerned about the TNC, the total non-structural carbohydrates that are in the plant, and how those can affect regrowth and plant vigor. But most time with our grazing management, we're trying to manage the amount of leaf area that we leave. And we do that with the level of defoliation that occurs. And depending on the plant species we're working with, we can actually defoliate plants at certain stages that will actually then stimulate additional tiller development. And again, of course, we usually rest for the plants, and we're grazing then trying to meet the animals' needs. And many times we can indeed do that with various grazing programs or grazing systems that are available. Sometimes we talk about overgrazing or overuse, and that can occur, but really one of the better ways to define that, rather than maybe removing too much of the leaf area, is maybe overgrazing as we just haven't provided rest for the plants. So here's some information to share is that, we need to allow time for these plants to rest, to recover their vigor following defoliation. And the late summer time frame is going to be most important for our warm season grasses. And in our system, I'm talking about kind of August and September. If we had cool season grasses that we're working with, then summer rest would be important. Before we get into how do we go about maybe controlling or managing various brush and weed species, one needs to be concerned or aware of why do these plants invade. And of course, in eastern Kansas, it's pretty obvious that if we take fire out of the system, we can go to a forest in a matter of about 3 or 4 decades. But woody plants invade in the rest of the state as well, maybe just not as rapidly. Climatic fluctuations do occur. We're kind of in a dry period now. Drought indeed can benefit certain species over others, or at least maybe some plants are able to survive drought better. But then on the other extreme, during wet periods, we can also have that may favor other species. Seeds are transported by animals, wind and water. Overuse by grazing by domestic livestock indeed has been associated in some cases with brush and weed invasion. And again, with tame pastures, oftentimes we need to make sure we're using good fertility. So bring these to your attention because it's important to understand, why these unwanted plants may invade, because otherwise we may just be treating a symptom rather than trying to solve the problem. So weeds, of course, are plants growing out of place. Here's a list then of some annual, biennial, and perennial species that we have in the state. I'm not going to talk about all of these. If you have questions at some point today, you can ask questions. But I'm going to talk about the 2 biennial species listed, musk thistle and common mullein. And then the perennials, I'm going to talk about primarily curly cup gumweed. But again, if you have questions about these others, bring them to my attention. The brush species then, the unwanted woody plants, a number of those. We have shrubs, the smaller growing plants. Many of these are multi-stem species. Buckbrush is pretty common. I'll talk about control of that species, as well as the rough-leaf dogwood. Blackberry and Molliflora rose are probably more problems in eastern Kansas. Eastern red cedar is starting to occur throughout the state, so I'll talk about management of that species somewhat as well. So as we think about control and management, these are kind of our toolbox or the options that we have available to us. Remember, I'm a range guy, so I've got grazing management there at the top of the list, and we'll bring that in a little bit, but primarily, again, maintaining cover and not overgrazing becomes important. But then we have mechanical methods, prescribed burning, biological control, and then the use of herbicides or chemical control. So before we get into those, though, again, I want to point out that some of these plants that we think of as weeds may actually have some value to them. They can add to the production and forage quality for grazing animals, for instance. We know that sheep, goats, and deer browse on the woody plants, but cattle eat certain woody plants at given times of the year as well. These plants help protect watersheds. Legumes that we have in our pastures at least have the potential to fix nitrogen. During the summertime, trees or things like that can provide shade then for cattle and then for winter protection as well. And then wildlife species use many of these this diversity of plant species that we have for cover and food sources. So here are 4 species, and again, these have been shown to be eaten by cows here in the Flint Hills where I work, but these species occur throughout the state pretty much. And, dotted gayfeather is pretty common. It's a late bloomer liatris species. Heath aster is our most common aster in the state. Lead plant is a shrub. It's a legume, but cows eat it fairly frequently. And then a native legume, purple prairie clover, is another one that livestock will tend to consume. And these type of species, we know that cattle are grass eaters, but typically more than 25% of their diet, assuming these other plants are available, will be made up of things other than grass. So as you think about then getting into control options, mechanical control, again, hand tools, these little loppers we might take out and cut individual plants off. Mowing machines can be beneficial, maybe for working with smaller stem shrubs or for herbaceous plants, weeds, particularly the annuals and biennials that are reproducing by seed. We could mow in a timely fashion to prevent seed production. And then we have the 2 examples of tree cutters here, the turbo saw there on the top and the hydro axe on the bottom, both clipping woody plants right off of the soil surface. And then an extreme example would be using a bulldozer to shear trees off. So eastern red cedar is a non-sprouting species, and here's a demonstration where they're using a tree cutter, cutting it off right at the ground level. Very effective on eastern red cedar since it doesn't resprout. What about prescribed burning? We know that prescribed burning has been used for a number of years to enhance livestock gain, particularly then with stocker animals. We can improve grazing distribution, and then we can use prescribed burning as well for brush and weed control, depending primarily on timing to a certain extent. Most woody plants, for instance, about need to be leafed out in order to cause much damage with fire. The exception to that, of course, would be eastern red cedar, since it's an evergreen, and anytime we can get a fire to carry through a stand of eastern red cedar, we can do some damage to that species. So here's an example then where eastern red cedar was burned. This is up in north central Kansas, again, Smith or Jewell County, that part of the state. Again, some of these trees are several feet tall, and you see they're desiccated. The brown needles clear to the top of those trees. So you had to have a pretty good fuel load to do that. Maybe 1,000, 1,500 pounds of fuel plus probably a little more wind and lower humidities that would help in order to carry a fire and control eastern red cedar. The best example we probably have for biological control would be the musk thistle head weevil. So here's a picture of both the adult beetle up there in the upper left, and then the larvae working in musk thistle, the terminal head. And these have been effective in reducing stands, although we still have plenty of musk thistle in the state, but I don't see those dense stands maybe as I used to see. And I think the head weevil has indeed helped reduce seed production over a period of time. One of the regulations that have come about though here in the last couple of years is that we're no longer supposed to be transporting Rhinocilus conicus across state borders. But as I go about this throughout the state of Kansas, like say across the north central part of the state and eastern Kansas, it's pretty rare when I don't find some musk thistle head weevil during the month of June, where the larvae are either working on the head or the beetles are starting to emerge. I've got a picture here of some goats. Is that biological control, or at least using a different animal helping us with our grazing management? And you can see these goats have done a pretty good job here of defoliating this woody plant. This happens to be salt cedar down in Meade County. But by defoliation of these plants, allows the light to reach the soil surface again. And if there's herbaceous vegetation there, then it will start to recover over time. Chemicals, of course, we use those for treating unwanted species, and those can be broadcast, or we may use spot treatment or individual plant treatments, different volumes. By ground, we might be talking about 15, 20 gallons per acre. By air, maybe 2 or 3 gallons per acre. What I usually think of high volume treatments, so I'm thinking about maybe 50 to 100 gallons per acre. So different volumes. Then we have basal and cut stump treatments. We'll hear some about that from Keith here later. And then some of our products we have are actually soil applied, either in a pelleted form or as a liquid. So I'll get into some individual plant data. And so start here with musk thistle. And musk thistle is a statewide noxious weed. It's been in the state for many, many years, since the 1930s. Again, in any given year, maybe the estimates is about 750 to 1 million acres being infested with musk thistle in the state of Kansas. So there's plenty around. You can see it in the photos here at the bottom, the rosette here on the left. The plant spends most of its life cycle in that stage, maybe 90% of the time. It's generally a biennial, meaning it may germinate in the spring of the year, grows all summer long in that rosette stage, goes through the winter and bolts and flowers in the second year. So it took 2 years to complete its life cycle. So here we have a bolted thistle without showing any flower color. I like to show people that picture because most all the herbicides that we have for broadleaf weed control will control musk thistle if you catch it at that stage. However, once they start to bloom, as you see there on the right, then that list goes down and control usually is reduced. So in this study, there were actually 3 dates of application there between May 16th and the 29th. Let's focus on the right-hand column because there's lots of data here. And if you go down these right-hand numbers here, you can see 90 to 100% control. And those were probably in that mid-May treatment date with these particular compounds. Again, the lower treatments then were probably, the May 29th. So that's why the range. But milestone, of course, is aminopyrrolid. Open side is the same as chaparral. It's aminopyrrolid plus metsulfuron. Then we have maybe our longer term standard type of treatments on musk thistle, Tordon 22K plus 2,4-D, and Escort plus 2,4-D. If you wanted to compare the prices on these products, actually the most economical treatment there would be the Escort plus 2,4-D because they're just much cheaper than those other products, although they all are quite effective. Another set of data on musk thistle control was from a December treatment. And again, I was using the milestone, Tordon, 2,4-D, and chaparral. Again, so at the time these plants were treated, there have been some freezes. but the plants were still green, had some green tissue in them, so that they would absorb a herbicide. Frankly, all these herbicides controlled the rosettes that were present at the time of treatment. However, when I evaluated the plots then the following July, then you can see there are certain treatments were much better than the others. And the difference is that Milestone and Tordon and Chaparral have chemicals, particularly the aminopyrrolid then and picloram, that have some soil activity, but they also carry over. They have some residual activity. So they work much better in terms of taking care of new seedlings, that following spring compared to something like 2,4-D. Okay, what about common mullein? It's another introduced plant like musk thistle. It's a biennial. So again, the top photo that you see here is showing in a rosette stage. What really characterized this plant, it's a very woolly or hairy plant. And this picture was taken, I think, in April. Then May, June rolls around and the plant will bolt and flower. Gets a small, fairly dense number of yellow flowers on a head there, somewhat like a wand. These plants can get quite tall, maybe up to 7 feet tall. Because of that woolly nature of the leaf, though, herbicides, if they're going to be effective, probably going to need to have a non-ionic surfactant to help get through that leaf surface. So here's some data. Actually, this is from Nebraska, and it was done Blue Hills up off of 281 there in kind of south central part of the state, as I recall. And again, they had both some spring and fall treatments because mullein can be a rosette in the fall time of the year. So again, the treatments that they used, or that I'm showing here, again, the picloram treatments, Surmount, picloram plus fluoroxypyr, Overdrive, if you're not familiar with that product, that's a dicamba product with diflufenzapyr in it. Cimarron is basically the same as Ally or Escort, just a different trade name that was used at the time the study was done. And then Clarity, of course, is the dicamba product. So you can see all those treatments on common mullein when they were rosettes in the spring were highly effective in this study. And they did have NIS in all these treatments, and they also used ammonium sulfate on a 2% volume to volume basis. However, when you look at the October 18th ratings, you can see some of these treatments were quite effective again. The picloram treatments, particularly Tordon 22K and Surmount, giving nearly 100% control. But some of these others, like Overdrive, was not very effective. Cimarron was not very effective in the fall as well. And as you look at those Ally Escort type labels, and maybe even on dicamba labels, if we don't have good growing conditions, if it happens to be dry, those products may not be too effective. So in the fall, there are some treatments that would be better than others. Again, from an economical standpoint, again, if you use, and I'll switch over to my data here, where I'm using a quarter of an ounce, that 2 to 3/10 ounce of product of metsulfuron is going to be the most economical product in this entire list. So here, if we look at the 101 days, a little over 3 months after treatment on studies that I've done here in north central Kansas, again, there's the Milestone Forefront, which is aminopyrrolid plus 2,4-D, quite effective. The metsulfuron at quarter ounce was also effective by itself or sticking Weedmaster with it. One thing I'll point out to you, though, you look at the Overdrive by itself, 4 ounces, is 81% control. But then when I stuck Overdrive with Ally, control went down. So it must have actually been an antagonistic thing that occurred there where it was not as effective probably as either product used alone, which that's unusual, but it can indeed occur. Another species I was asked to talk about, because it seems to be showing up a little more, is curly cup gumweed. And it's a plant that it can usually no more than 2 feet tall, although it can get big if it's in a place where little competition occurs. And typically that's where you're going to see it on disturbed sites, maybe along trails or open areas. It's considered to be a short life perennial, meaning it doesn't live for decades, maybe 2 or 3 years, or occasionally it'll act like a biennial species like musk thistle does. As you try to identify that one, of course, it has this yellow flower on the top, but if you touch this plant, you'll see that it's very sticky throughout the plant, very noticeably, and that thus the name gumweed. The leaves themselves, they alternate as they go up the stem. There's no petiole. In other words, that leaf is pretty much an oval-shaped leaf clasp onto the stem. And then you'll have kind of rounded or coarsely toothed margins on this particular species. Again, some work I did, pulled out of my archives from a number of years ago. I was looking at the impact of overdrive, although I didn't try overdrive again, which is dicamba by itself in this study for some reason, but we looked at combinations then with picloram. And you can see, again, this is ratings 5 weeks after treatment. And some of these were pretty effective. There's picloram plus overdrive, there's 98%. The LSD here is 20, meaning if it's 85, the 32 fluid ounces by itself I can't statistically say it was less than the other treatment. But you can see maybe some minor differences. I'm not sure why the 16 fluid ounces of picloram plus 4 ounces overdrive was lower, but that's research sometimes. Again, but looking at the economics here, those two treatments, let's say the straight Tordon 22K, that 32 fluid ounces, that's a quart. That's multiple times what we use on musk thistle, for instance. Well, that's a pretty expensive treatment, nearly $18 just for the herbicide. If we go down, though, where we had 8 fluid ounces of picloram and 4 ounces of overdrive, similar control, that's a little bit cheaper of a product for treating gumweed. However, if you look at labels and see what other herbicides are available that should indeed control curly cup gumweed, here's a list. Chaparral, again, which is the metsulfuron plus aminopyrrolid, 12 to 15 bucks. That's cheaper than those other products. Duracor is a relatively new product that Corteva has released. It has the aminopyrrolid in it, but then it also has a product we call Rinscore. Again, less than 10 bucks an acre for that herbicide. Grazon, if it works at 2 pints per acre, would be cheaper. And then, Grazon Next is also there. So almost all these treatments here are cheaper than the ones that I'd used in another study. And that sometimes it boils down to, do we have an individual target species or do we have multiple species we're trying to control? Because some of these might be better, have a wider range of species they can control than others. So here's our friend Eastern red cedar that occurs throughout the state of Kansas, getting to be quite a problem. I don't have any data necessarily to show you, but here's my pecking order in terms of trying to control Eastern red cedar. And, my first choice, if I can burn, that's probably what I would use. It's very effective on small trees. And even larger trees, we can use our management to provide enough fuel to carry a fire, or even cutting off some trees, stacking them under larger trees, running a fire into that can be effective for burning down large red cedar trees. Mechanically, again, if we cut them off below any of the green branches, that's an effective control because this species does not resprout. If you want to use chemicals, there are some available. Picloram as a liquid is Tordon 22K. That rate is 3 to 4 mils per 3 foot of plant height applied to the soil. Hexazinone is the active ingredient then in Valpar L, which is a liquid, or also in Pronome power pellets, dry material. Those can provide some control as well. And then if you use high volume applications of Escort, 1 to 2 ounces in 100 gallons of water, or that 1 to 2% surmount in water can also control Eastern red cedar. But again, you get some differences here in terms of cost when you start comparing these various options. What about buckbrush? It's a fairly common shrub that occurs throughout the state, across north central, clear to northwestern Kansas, you can find it. There is a related species I'll show you a picture of, but it's a smaller growing plant, often grows in clumps. get colonies. Buckbrush actually has stolons that grow across the top of the ground. I know if you try to walk through these and drag your feet, you might even get tripped. A related species then that you have in starting kind of in north central Kansas, going to the northwest, would be this western snowberry. So here on the left, this is the snowberry, and here on the right is buckbrush. Again, this picture I think was taken in Jewell County, and they were both growing there then together. Again, when you see them together like that, well, I could tell them apart. If you saw just one or the other, it's probably a little more difficult at this stage. They both seem to have somewhat ovate leaves. However, once they bloom, flower, and they don't have real noticeable flowers, but when they produce the seed, the snowberry will have a white berry on it, and buckbrush has a red berry. Sometimes these plants indeed are called coralberry. So a little data then from buckbrush control, some different dates of application from different studies I've done here in this general area. And of course, if you catch buckbrush at a proper stage after it's leafed out, just before these leaves, they'll kind of go from a light to darker green color. And just about the time that's occurring, that's the ideal time to treat buckbrush with a foliar applied herbicide. And that usually occurs by that mid-May timeframe. And you can see that even late May, 100% control with 2,4-D low volatile ester. But as that plant matures and the leaf probably is building up a cuticle, control then goes down. Chaparral provided good control there on that May 28th date, but then you see it falls off. You might be able to extend control with chaparral by sticking some 2,4-D with it, because you can see there on even then into early June, we're getting similar control with the chaparral plus 2,4-D as we had with the 2,4-D low volatile ester. Grazon can be an effective treatment on buckbrush. Tried Cimarron Plus, which is a combination then of LI and Glean, and you can see that it was not very effective. So again, for buckbrush, burning can be very effective. It's usually leafed out at a time of the year we can burn. It may take 2 or 3 years in a row to completely burn through those stands, but that can greatly reduce buckbrush. Repeated mowing at an early stage after it's leafed out, and we have a low point in that carbohydrate cycle, which again is generally in that early to mid-May time frame, that can be effective. And then we have these chemicals that we just talked about. Roughleaf dogwood is another shrub that we have, although it can become a small tree, frankly. It blooms a little later, and the timing would be different than it would be on buckbrush. You can see the plant is still in a bloom stage, has those white flowers and umbel shape on the top of the plant. That generally occurs in late May or up to middle of June. So that's a time frame we usually think about trying to control it, at least with a herbicide. So here's studies I had done, screening a number of products. This actually summarized 2 locations over 2 different years of application. Before we did this study, I probably was recommending a combination of remedy plus 2,4-D. Well, you notice in this study, the ratings a year after treatment when mortality is determined is only 17%. So that's not very good. So that sure changed our thought on maybe what we ought to use to control it. So you can see these products at the top of this chart, all the way from Banville plus 2,4-D down to the Tordon plus 2,4-D. They'll all defoliate roughleaf dogwood. A month after you treat them, the leaves seem like they're brown and falling off, but you come back a year after treatment and the mortality just isn't very high. They're leafing back out, or they've resprouted from the base, or maybe even from above ground stems. So Pasture Guard at 1%, again, this is a high volume treatment, 1%, that'd be a gallon of Pasture Guard with 99 gallons of water, gave 50% mortality. Then you can see the other ratings there with Surmount, and then this 3-way treatment, which is probably what I normally would recommend anymore, is if we take a picloram, maybe a pint of picloram, 2 pints of 2,4-D, and a pint of remedy. You put those 3 herbicides together, you can kill most woody plants. But as you can see, the mortality is not real high. This is a pretty difficult plant to control. In fact, maybe using some integrated approach where we're combining treatments might be more effective. Maybe we burn it off, top kill it in the spring, let it resprout and treat those resprouts. Or we could mow it off and the same thing would happen. It would regrow and then we'd want to time it. And from what we understand from the carbohydrate cycle, waiting about 4 weeks would be the thing to do after that top removal with fire or mowing. We can also use spike pellets to control rough leaf dogwood. We've done that. Again, and we've got mortality at least in that 60 to 70% range using spike 20P. So as we think about using all these herbicides, just want to remind you there are some grazing restrictions, or as you look at these, although most of the products we use, frankly, we can do that with beef animals in the pasture. There's no waiting period before you graze. However, if you're looking at hay production, then there's some, it varies depending on the herbicide. And you can see the numbers there for slaughter. I see that 30 days on Banville. I went back to found an old Banville label that's still being marketed, and indeed it said 30 days. But most time that 3 or 4 days before slaughter is important to watch that. So to summarize what I've presented today, again, you need to treat these woody species when they first show up. The longer you wait, the cost is going to go up. Treat it when that first plant comes out there, particularly if it's got the potential to be a problem species. I rarely recommend broadcast application for control of broadleaf weeds unless it's indeed affecting maybe grazing distribution, or if I'm working with a noxious weed such as musk thistle or Sericea lespedeza that might indeed warrant a broadcast application initially. So proper grazing management, looking at stocking rates and rest and things like that, use of prescribed burning where we can do that, spot treatment with herbicides. If we do all those sorts of things, generally we will prevent extensive tree and brush problems. So with that, I think I'm finished presenting and be glad to address any questions that you might have at this point.
Okay, thank you, Walter. Right now, there was one question in the chat, and it was actually mentioned that by Sandra, and it was brought up by Keith that he was going to answer this question in his presentation, but I will go ahead and bring it up now because maybe Keith or Walt might have another take on it. But it was, why did the curly cup gumweed show up more this year? And do you actually need to control this weed? Is it something that will become a problem if we don't do something about it?
Well, again, I don't, a lot of times these plants show up, maybe rainfall patterns will affect them. Keith, I know he'll talk about how dry periods affected Western ragweed, for instance. So we can see that variation from year to year. Most of the time, there's a threshold. These plants have to get to pretty high density, frankly, before it's going to be economical to control them. And again, I know Keith will visit with you about that. So again, sometimes it's like treating dandelions in your lawn. Sometimes we do that just for aesthetics. We don't like the look of them, but it may not indeed be putting anything in our pocket. Because even if I go out there and with a pound of 2,4-D, if that would work, and I don't know that I'd work on that particular species, but that's going to cost you a few bucks an acre just for that herbicide, right? And you put on how the application costs, you're getting up 10 bucks or more per acre pretty quickly. Are you going to get that back by treating some of these broadleaf weed species? So it's something one needs to think about, but that's got to be pretty. I think most of these have to be pretty dense before we need to get too concerned about them. Now, if I had a poisonous plant or something, that might change how I respond to that question. But I think with the typical broadleaf, that's how I would approach it.
All righty. And at this point, we don't have any more questions in the chat, but I encourage anybody, if they have something that came up after Walt finished up, go ahead and put that up in the chat, and we will get to it at the end after Keith's presentation. With that, I think we have Clint coming on, and he will introduce our next speaker, who I've prefaced a few times. Go ahead, Clint.
Okay, thank you, Brett. I appreciate the introduction. Again, everybody, we want to thank you for your time today. We know your time is valuable, and hopefully you guys will learn something. It's my honor to introduce Keith Harmony. Keith is the Professor of Range Sciences at the KSU Research Center in Hayes. Keith arrived at KSU in 1999, where he's conducted grazing trials on modified intensive early stocking strategies and complementary grazing systems for the beef cow-calf producers and production. He also has performed forage evaluations on the growth and persistence of several perennial cool season grasses for adaptation to the climate of western Kansas. Another major aspect of Keith's research has involved the suppression or control of weedy plant species that have significant impacts on rangelands, particularly the honey locust, Japanese brome, and Old World bluestems. Keith, the floor is yours.
All righty, well, thank you very much, and I'll get my screen popped up here. Walt gave a really nice introduction to this two presentation series, and a really nice introduction, and then went on to talk about some particular species and their control. And I'm going to continue on with that, and I'm going to be talking about a few particular species, namely honey locust, yucca or small soapweed, and western ragweed in pasture. And first I want to bring up honey locust. And the home range of honey locust, its native area to the U.S., is basically the Ohio River Valley, Mississippi River Valley, and the eastern portion of the Great Plains. And over the course of time, over here on the right side of the screen, that map, that range of honey locust has spread throughout most of the lower 48 states of the U.S. over the course of time. And I'm going to talk a little bit about that and the reasons why here in just a moment. But honey locust by itself as a single tree, it has really small leaflets, and it allows some light to pass through those leaves. And so a single tree doesn't really shade a lot of grass. But when you put several trees together and form a dense canopy, there's a lot of grass that gets shaded, and it'll reduce production of a pasture where we have basically some solid stands of this occurring in some riparian areas and starting on some upland areas. But one of the main things that honey locust is known for is its characteristic thorns. And these thorns are a risk to livestock and a risk to humans because they are definitely sharp, and they can produce some really deep punctures in an animal or in a person. And that's also the case with equipment. There's been innumerable tires that have fallen victim to these thorns when people have driven out and checked animals, or just gone out and done other things in pasture and driving through a grove of these honey locust trees. And so they're a hazard to people, and they're also a hazard to equipment. And one of the ways that these honey locust trees get spread throughout a pasture is through the pods. The pods are high in quality. They actually have a very high protein content. Animals readily eat them, and they will spread them across the pasture. And deer do consume those pods, and a study in the Cross Timbers area of southern Oklahoma showed that 4% of a doe deer's diet during the fall and winter consists of honey locust seeds. And so they do consume it, but I don't think they're probably a major cause of spread throughout a pasture where honey locust is found. But cattle are a major cause of honey locust being spread throughout a pasture. In pastures where there are stands of honey locust trees in, say, a riparian area, cattle that graze in those pastures in the fall and the winter, they readily eat those seed pods and the seeds, and then they deposit those in cow pies all throughout the pasture. And here we see a picture of a cow pie that was deposited in the prior fall or winter, and I'm outlining it here with my arrow. And it's weathered some, but right in the middle of that are 5 new honey locust seedlings starting to emerge out of that cow pie. A cow pie is a perfect environment for a seedling to get started. It's high in nutrients, and it also retains moisture very well once it's wet. And so it's a perfect environment for getting a plant started. Another reason why we have honey locusts increasing in pasture was alluded to by Walt, and it's fire suppression. A prescribed fire that would go through a pasture where, say, that cow pie from the previous slide was located, a fire going through that pasture would readily burn those little seedlings that were starting to emerge. And so occasional fire or periodic fire going through a pasture will help control some of those young seedlings that would start to inhabit a pasture. So fire suppression is another cause for us seeing more honey locusts and other woody species in pastures. And we've also spread honey locusts to different areas ourselves. There are thornless varieties of honey locusts, and some of those old thornless varieties, even though the tree themselves didn't have thorns on them, a lot of those old varieties did have the capability of producing seed, which then would produce a seedling that had thorns. Up to 40% of the seeds had that genetic potential in them from some of those old varieties that were planted in shelter belts throughout the Great Plains, and also used as ornamentals in homesteads and also in parks and things like that. So we helped increase the presence of honey locusts ourselves. Honey locusts will also spread in a pasture through resprouting. Once a honey locust tree is cut, that stress on the tree causes buds to activate, and it will initiate a sprout to emerge from those buds. And this is actually a photograph of a honey locust tree that was cut, and then it was actually treated with a triclopyr plus diesel mixture. But even though it was treated, we can still see a ring of sprouts coming from around the base of that stump. And that is pretty much unacceptable control, and it's another reason why we see more trees out in pasture from people cutting them down and possibly not treating them or not getting an effective control from a herbicide that they used. So some of the common methods for trying to control honey locusts in pasture, there's foliar treatments, and we spray to cover all the leaves in the spring once full leaf emergence has occurred. And then Walt alluded to some of these other methods as well. In his talk, we have the cut stump method, cutting the tree off and treating the stump, frill or girdling. And then we also have a basal bark treatment. Now, out of these, the cut stump, frill or girdling, and the basal bark, those methods can be done any time of the year. The labels on most herbicides state that those methods are acceptable during any season, spring, summer, fall, or winter. The one limitation that we do have is for the basal bark treatment. And that treatment can be done any time of the year as long as the trunk or the bark is not wet from snow or rain. That snow or rain will keep the oil penetrant with the herbicide mixture from getting through the bark into the growing layer of the tree. Here's an example of a honey locust tree that was cut down, and then the outer part of the stump was treated. The live part of the tree, when it was cut, is actually where this dark band is around the outside of that stump. It's weathered differently than the dead portion on the inside of the stump. And so when a tree is cut down, a honey locust tree is cut, it is this outer area that needs to be treated with the herbicide. On larger trees that may be kind of dangerous to remove or cut down yourself, and you just want to treat them while standing, you can what's called frill or girdle, and that is where you take a chainsaw or a hatchet and you cut a ring, a 1 to 2 inch ring, all the way around the tree or in sections around the tree. And by cutting into the tree, you're cutting through the bark and you're getting to that live cambium layer of the tree. And then you apply the herbicide into that ring. And that will allow that tree to take up that herbicide in that living layer and to translocate it to the roots where it needs to be translocated to control the tree. We also have the basal bark application, and that is performed on a tree that's left standing, is not cut, no mechanical treatment done to it whatsoever. And the herbicide plus oil carrier mixture is applied to the lower 15 inches of that tree all the way around it. And if you have additives or some other penetrants included in that mixture, you may be able to also use what's called the thin line basal treatment, which Walt alluded to in his earlier talk. But anyway, one limitation with this is it on the labels where basal bark is able to be applied to a tree with a herbicide, the limitation is usually a 6-inch diameter tree or less that it's allowed to be applied on. Now, I had mentioned earlier that, or had shown a picture of a stump that had sprouts around it that was treated with triclopyr plus diesel mixture. And I had received numerous phone calls from producers and agents that one of the treatments that we'd been talking about for a long time for honey locust control and pasture just didn't seem to be performing as well as it should have. And it was that triclopyr plus diesel mixture. That there were a lot of folks that were using that method and they were getting a lot of resprouts or more resprouts than what they thought they should be getting. Well, about the time I was getting those phone calls, aminopyrrolid or Milestone had come out with a new label with new wording in it that allowed for it to be applied as a basal bark treatment on honey locust trees, or it could be used as a treatment on a cut stump. Those weren't on the earliest labels, but they were added on later as it was in production for a longer period of time. So anyway, this was a good opportunity for us to test those different mixtures, triclopyr and aminopyrrolid, and using it on different application methods. So in a study that we did in 2012 and 2013, we looked at triclopyr plus diesel and aminopyrrolid plus bark oil and applied those two as a basal bark treatment on honey locust trees. And then we compared it to 3 stump treatments. And those 3 stump treatments were aminopyrrolid plus water, dicamba plus 2,4-D plus water, and the same triclopyr plus diesel that was applied as a basal bark, but we applied it as a stump treatment. And we applied each of those to 50 trees each year, or in the first year, and 40 trees in the second year. So we had a very large sampling of trees that we applied these to. And what we were looking for is 1 year after treatment, we came back to these trees and evaluated them to see if we had dead trees. And with the trees that were treated with basal bark treatment, we basically looked to see if there were any live green leaves left on the tree. If there were any green leaves at all, it was counted as a live tree. But we also looked at sprouts around the tree. And in a 6-inch radius around each tree that was treated basal bark, or each tree that was cut and the stump was treated, we looked in a 6-foot radius around each tree looking for sprouts. And if we saw any sprouts, that tree was counted as a live tree rather than a controlled or dead tree. And so this is an example of what we are looking for. On the left, you can see a honey locust tree that was cut and treated. And I have circled here in black 6 sprouts that came up from treating that tree. Now, there may be sprouts that were emerging 15, 20 feet away from this tree, because those roots from a tree can extend along a great distance. But we use the 6-foot radius because we're pretty confident that if there was a sprout within 6 foot of a tree that was cut and treated, or that we applied basal bark, that sprout probably belonged to that tree rather than another tree that was located 20 or 30 feet away. So we counted all these sprouts within a 6-foot radius of all the trees that we treated. And what we found, averaged over the 2 years, was that with the basal bark treatments, we got much better control with the aminopyrrolid plus bark oil treatment than we did with the triclopyr plus diesel treatment. Over 20% greater control with the aminopyrrolid. At looking at the stump treatments, we also got much better control with the aminopyrrolid and with the dicamba plus 2,4-D treatments than we did the triclopyr plus diesel treatment. And looking at these, even though the dicamba plus 2,4-D treatment had statistically equal control, it really looks to me like the aminopyrrolid treatments were far and away the top treatments here. Each one of those just barely under 100% control, which was basically one tree and I think 3 trees that were having sprouts at some time. And here is a summary of the percent of trees with sprouts. And it was one tree and three trees with those 2 treatments that produce sprouts. But in looking at the count of sprouts per tree, they also had a low count number. When it did produce a sprout, it was a very low number of sprouts. Now you compare that to the triclopyr plus diesel treatment, especially the stump treatment. 46% of the trees cut produced a sprout and had almost 5 sprouts per stump. So that means if we started out with 100 trees and had 46% of them with sprouts and almost 5 sprouts per tree, that means we started out with 100 trees, but we ended up with over 200 sprouts. So that basically was an ineffective treatment in this study. We also looked 2 years after treatment and looked at the same thing. We looked at new sprouts and basically found that the triclopyr plus diesel as a stump treatment, again, had more sprouts and a percentage of the trees having sprouts than the other treatments. And this was a common thing that we saw with the basal bark applied treatments in that study, that there was a small dead zone around the tree. And that, I believe, was basically from the diesel fuel or the bark oil carrier, as it could have sprayed or splashed off the trunk and landed on some of the vegetation near the trunk. There was this small dead zone the year after, but 2 years after treatment, this pretty much filled in most all cases. We also saw what is called flashback, especially from the aminopyrrolid treatment. And this was basically from us treating small trees. And here it's indicated by the blue arrows, and you can see the white stakes. Those were markers depicting where we treated some of our stumps. And these were treated with aminopyrrolid. And you can see that there are some larger trees that are basically 15 to probably 30 feet away that are honey locust trees that also died. Even though these trees were much too large to be included in our study, the treatment of these smaller trees close to them, they had to have been connected by their root systems, and that aminopyrrolid herbicide was translocated through the root system to those larger trees and controlled them. And this was really evident by another tree. This was about a 20-inch diameter tree. And we treated 2 small stumps that were probably 15 to 20 feet away from this tree. And we ended up killing this large tree, even though we never applied any herbicide to it. So in summary, with the honey locust study, the aminopyrrolid treatments were very effective at controlling honey locusts. And within a couple years, the bark and some of the branches started sloughing off of these honey locust trees after treatment. So some recommendations for honey locusts for small trees and seedlings: you use a prescribed burn regimen, periodic fire to help control those trees, but also most any herbicide that's used for musk thistle could also be used to treat small seedlings and small trees up to probably 3 or 4 foot high, as long as adequate foliar coverage takes place. Basically need to make sure that all the leaves are covered with the herbicide, and most musk thistle herbicides are going to be able to control or suppress those smaller trees. For trees that are a little bit larger, up to 6 inches in diameter, you can basal bark treat the lower 15 inches with the aminopyrrolid plus bark oil. It was very effective. And for larger trees, cutting the tree down and treating the stump, or doing a frill or girdle with aminopyrrolid and water, or the dicamba plus 2,4-D were more effective in this study. If you do want to use triclopyr plus diesel to try to control honey locust trees, I would only use it as a basal bark treatment rather than as a stump treatment. And for the densest or tallest stands that basically just have too many trees in them to feasibly be able to perform individual tree treatments, broadcast foliar treat aerially with aminopyrrolid plus 2,4-D mixture, or a picloram plus 2,4-D mixture. And with the densest and largest trees, add triclopyr in there as well. And that was a mixture that Walt alluded to earlier as being one that can pretty much be effective on most tree or brush species. So in looking at doing an aerial treatment on honey locusts, coverage is important. And in order to get better coverage on trees in the canopy so that the lower leaves can also have a greater chance of getting herbicide on them, you can use more gallons per acre carrier. You can also spray from 2 different directions, or you can spray in 2 out of 3 years. All those things will help increase the coverage, but they're also going to increase the cost. But you will get better coverage using those methods. I have put together here a small little spreadsheet of some different herbicides that are effective as a foliar treatment, or different mixtures that can be used as a foliar treatment. I'm not going to get into this right now and cover all these, because I believe we're going to have this available for you all to look at after the presentations are over. So I think you can get on the web and look at these more closely. And I also have the same type of spreadsheet here for bark and stump treatments, and you'll be able to check those out later on, I believe. So right now, I guess I would just quickly stop to see if there's, just one quick or 2 quick questions about honey locusts that I could answer before moving on to the next area. If anything's popped up on the chat.
We currently don't have anything in the chat, Keith, but I will ask one question, and it's going to be a broad one. What is the biggest reason that the cut stump method and application fails?
Okay, why did the stump treatment with the triclopyr plus diesel fail on honey locust?
Yeah. Well, not just that, but in general, when guys are out treating them, even if they use the correct treatment of the imiprolid.
The triclopyr plus diesel treatment is actually very effective on other species. It just seems to not be as effective on honey locust, but it's very effective on other tree species. I believe it's because when that tree is cut down, it changes the apical dominance of all the buds and all the growing points in the tree, and I just don't think it translocates. It messes the hormone system up in that tree, and it just doesn't translocate as well. I have no way to prove that. That's just what my speculation is. However, the aminopyrrolid, it appeared to translocate very well in that, and we saw that flashback in getting other trees that were connected to the root system.
Okay, I don't see any other questions in the chat, so as you were.
All right, I'll continue on then and talk about yucca or small soapweed. And it's found throughout the Great Plains from Mexico all the way up to Canada. Very common here throughout Kansas. Grows well on dry slopes and dry uplands. And it also can grow very well in loamy and rocky type soils, some sandy soils. It is adapted to most locations in Kansas. It's semi-woody and stemless except for the flower stalk that it puts up every spring. And the leaves are very fibrous and thick and prickly. But even though it is very fibrous, deer will browse on the tender whorls of yucca plants. And they also will feed on the flowers and the young pods of yucca. And if anybody has ever watched cattle turned out into a new pasture where yuccas are flowering, the cattle will basically run from yucca plant to yucca plant trying to eat the flowers before their neighbor does. So those flowers must either be highly nutritious or have a great flavor or taste to cattle, because they do love to eat those flowers as well. Yucca plants can form dense colonies. They have a very massive root system, and it's almost impossible to pull up a small yucca plant because of its root system. And because of those massive root systems, they use a lot of water or have a lot of water contained within them. And so they're able to use moisture that could be used by grass for grass growth, and the leaves also will shade grass. There are some herbicides that have some labeling for broadcast application to control yucca, and those are metsulfuron products, Cimarron Plus and Chaparral. Those two herbicides with metsulfuron have labeling which allow them to be mixed with 2,4-D ester to be able to control yucca as a broadcast treatment. And it is specifically labeled as 2,4-D ester that has to be used. And so with this labeling, Walt and I actually did a study. It was probably 10 or 12 years ago that we did in southern Trego County on a stand of yucca. And in this stand of yucca, we included these herbicide treatments with that labeling of supplementing with 2,4-D ester. And we performed this by counting all the yucca plants that were within a plot before we treated those plots. And then we based our control on the number of dead plants compared to live plants at the start of the study. So dead plants at the end of the study compared to the total of live plants at the start. And we applied these herbicides in June and in September. And we looked 1 year after treatment and 15 months after treatment. And this is what we were looking for. We were basically looking for gray yucca plants, which means they had died and had weathered. And we were looking for any signs of green. And if there was any sign of green, it was called a live plant. And that included plants that looked like most of it was dead, but there might have been green coming out of the whorls. Those were counted as live plants. Now, the treatments that we used were combinations of metsulfuron methyl products and 2,4-D. And the mixtures that we used that had the best control for the June treatment were the Cimarron Plus and the Chaparral treatment, but also the Escort plus Weedmaster plus 2,4-D treatment. Each of those had over 60% control as a broadcast treatment, with just one broadcast treatment. So averaged over the 2 years, compared to individually applying herbicide to each yucca plant, that was actually better control than what I might have been expecting. But it was pretty good control, especially when you look at Escort alone, 36%, and Escort plus Weedmaster was only 26%. Now, folks that are familiar with Weedmaster know that it has 2,4-D in it. But that 2,4-D is an amine formulation. And so metsulfuron methyl plus 2,4-D amine did not improve yucca control at all. But when that 2,4-D ester was included, it greatly increased the yucca control. The other treatment that had over 60% control from that June application was 2% Remedy plus diesel in the whorl of the plant. And that had 77% control in the spring. Now in the fall of the year is when most perennial plants are photosynthesizing and trying to store carbohydrates for winter storage so that they can stay alive in the winter and so they can start growth in the spring, produce new growth. And so I thought that the September application that we used, that we were going to see numbers even better than these numbers that we saw in the spring. But when we did our evaluations, basically every single one of them was more poor than the spring application. None of the treatments that were broadcast applied had over 35% control when we applied them in September. However, the Remedy plus diesel in the whorl had almost 90% control. So that individual treatment was very good. And I think that the reason that we may have not had as good a control in September versus June is I think that those leaves, as they went through the growing season, those yucca leaves hardened, and it was harder for those for that herbicide to penetrate into the leaf and get translocated throughout the plant. So what we saw the year after we applied the treatments was that we had many dead yucca plants, and we actually started to see some grass starting to grow up through some of those controlled yucca plants. And in some of the areas where we had the largest density of yucca plants, in some of the more dense colonies, we saw dead plants, but we often saw some plants still surviving, or some young plants that maybe escaped the treatment. So we had some decent control with some of the treatments, but we still saw some surviving. Now there's other ways that you can reduce yucca. Walt talked about fire earlier, and fire does reduce yucca leaf area and canopy cover area. And so fire can reduce the competition of yucca with surrounding grass, but it will not kill the yucca. The deep root and the deep growing point of yucca plants basically helps it to escape fire treatment. And so fire usually will not control a yucca stand, but it can help reduce the competition of the yucca with grass around it by reducing the total leaf and canopy area of the plant. Another way to try to reduce yucca is through winter grazing. Winter grazing has been shown in areas where it's been used. In some instances, yucca populations have been reduced. And basically what occurs is animals will get down and graze or browse on the lower portion of the yucca plant and will end up injuring it and end up controlling it. So some recommendations for yucca and grazed pasture. You can use a prescribed burning regimen to try to reduce the leaf area, the canopy area, so that there's less competition with grass. For small populations or sparse populations, I would use the 2% triclopyr plus diesel mixture. It seems to be a mixture that works very well, and you will not injure any grass around the yucca plant like you can with other individual plant methods to control yucca, such as using the hexazinone treatment that Walt talked about earlier. For really dense populations, a broadcast treatment of metsulfuron methyl plus 2,4-D ester mixture during flowering was the best treatment in our study. And controlling 60 to 65% of that stand puts a really big dent in that population. And then you may be able to follow up the remaining treatment of other plants with individual treatment after that broadcast application. That broadcast application can save a lot of time and money in labor and in herbicide expense from doing an individual plant treatment. So I'll pause quick and see if we have any questions on yucca control.
I will give anybody's chance to type anything in the chat, but in the meantime, I had a question. Maybe I did miss it, but are there any strictly mechanical control methods for yucca? You did mention cattle can damage it by grazing it in the wintertime. Can you mow it? Or?
There is mechanical treatment that you can do to basically pop the plants out of the ground with the tractor and loader or a skid steer or some sort of equipment like that. Because it has such a deep root system and a deep growing point, I don't know if that method is always effective, because they may be able to resprout. It's very difficult to get a plant out of the ground. It basically would take some sort of mechanical treatment like that with some sort of power equipment to get that done. Walt, if he's on and listening, I guess he may have some experience with that. I don't know if he's seen that done or know any producers that have used that method or not.
I had questions regarding that, but again, I think they're probably going to recover. They're going to resprout at some point in time. It might be similar to like when you burn. You get rid of that top growth, would get rid of some of the cover and so forth. But of course, depending what device you're using, you may cause some additional damage to the soil surface, though, compared to burning. So
yeah, that is true.
I don't know that'd be very effective.
It would definitely be costly.
Yeah.
Definitely be costly.
Okay, I don't see any other questions coming up in the chat on yucca at the moment.
Okay, well, I guess I'll continue on then. And the next thing I'm going to talk about is this nice bright green forb right here, and that is Western Ragweed. Western Ragweed is one of our most common perennial forbs in rangeland throughout the state. Forbs, as Walt mentioned earlier, can make up a significant portion of a beef cow's diet through the year. And it was found in some early studies done out here at Hayes in the 1950s and 60s that the composition of Western ragweed in our pastures during that time period ranged from 1% to 34% on a dry matter basis. So that's a pretty high composition. And in evaluating my grazing studies done here from 2002 to 2014, we had from 0 to 21% composition of Western ragweed in our pastures. So it does have quite a broad range of population from year to year. It can vary quite a bit. In that earlier study, that 1950s to 60s study, the yield of Western ragweed in the study pastures was 710 pounds an acre, which is, quite a lot. That's almost half of a large round bale per acre. And they found that 49% of the Western ragweed that was produced in the pastures those years, an average of 49% of it was consumed. So out of that 710 pounds per acre, I guess I shouldn't say 49% was consumed, but 49% of it disappeared during the growing season with grazing taking place. And in our studies from 2002 to 2014, yield of Western ragweed averaged just over 200 pounds an acre. So we have had significant populations of Western ragweed in our study pastures here at Hayes over the years. Western ragweed is a plant that has a very extensive lateral rootstock system. So a plant will form a lateral bud and will start a new plant growing next to it, similar to what grasses with rhizomes do. So you can have sparse plants that eventually turn into dense colonies. And we have some other plants that have that same kind of growth form. And I'm going to talk about those in just a little bit. But Western ragweed, over the course of time here at Hayes, has had fluctuation in its population. You notice here in 2006, and also 2011 and 2012, we had big reductions in Western ragweed composition in our pastures. And those 2 years, or those 2 time periods, are 2 of our driest time periods that we have on record. And so in years where we had a dry fall and went into a dry spring and summer the next year, we saw significant reductions in Western ragweed, where we had 10% of the composition in the stand the year before. So climatic variation and environmental conditions can be causes of some cycling of the Western ragweed composition in our pastures. So composition can be highly precipitation dependent. And I can tell you that over the last few years, where we've had significant amounts of rain above average out here at Hayes, our Western ragweed populations have basically been climbing each year. Now, about 10 or 12 years ago, I was doing a study where I was looking at the effects of a particular herbicide on different perennial forbs in pasture, and Western ragweed was our most dominant forb. And we were applying different levels of this herbicide in plots in our pasture, and that enabled us to produce stands of Western ragweed with variable populations, where it made up variable composition compared to grass in each plot. And so in looking at that data and graphing it, I basically found that there was a relationship between Western ragweed production and native grass production, and found that the inflection point of where Western ragweed composition will start to reduce native grass production was close to 35 to 40% of the composition being Western ragweed. So when Western ragweed started or approached 35 to 40% of the stand, as far as dry matter is concerned, it started to reduce grass production. And I went and looked at an earlier study done in the 1950s by John Launchbaugh, which he did on a site that was a more productive site, and looked at his data and how much ragweed was produced in an area before it started to reduce grass production. And it basically showed close to the same inflection point, that when about 40% of the population or composition of the stand was Western ragweed, the competition started to reduce native grass production. Now, I mentioned a little bit ago about some perennial plants that we have that have similar root forms and growth as Western ragweed. Walt talked about curly cup gumweed, but we also have Louisiana sagewort. This plant here on the right gets a white fuzzy surface to it. And we see it growing out in pasture, similar to what we do Western ragweed. Here's some small colonies of Western ragweed and Louisiana sagewort growing in an area that was disturbed next to a road. But we see areas of this where it may be making up more than 40% of the composition right in that direct area where it's growing. And there's some other plants such as some goldenrods may have similar production, where they have root stalks that can form dense colonies, that we may possibly see similar things, where when we get to a point where it is over 35 to 40% of the composition on a dry matter basis, that it may start to reduce grass composition in that area, or grass production. So when we talk about herbicide treatment, it's probably not going to be economical until it gets close to that 35 to 40% range of composition. And if we do approach that level in pastures, there are a few things that you can treat Western ragweed with that are very effective on control. 1 to 2 quarts per acre 2,4-D, or 1 to 2 quarts per acre of 2,4-D with some added dicamba. Aminopyrrolid at 5 to 7 ounces is effective, and so is 1 to 2 pints per acre picloram. And so when we have populations approaching that 40% composition area, it could be warranted to treat Western ragweed or some of these other perennials. But one thing that we do have to remember is that the environment and climatic conditions can cause some wide fluctuations, just like what we had here at Hayes in 2006 and 2011 and 12, that we saw significant population declines, even though we did no treatment whatsoever. It was just a natural occurrence of the environment at the time. And other perennial plants, I think, probably are going to be going through cycles like that as well. And a lot of times the problems that people perceive of weed problems out in pasture aren't necessarily production problems, but are more aesthetic problems than what they are production oriented. So when we look at treating Western ragweed or other perennial forbs in pasture, based on some of the graphing of those studies that I showed a couple slides ago, where if we treat Western ragweed on a low production area and we get 400 pounds per acre of new grass growth versus a more productive area where we get 1,000 pounds of production by controlling ragweed at a cost of $10 to $20 an acre, there's a significant difference in the cost per ton of new forage produced with those different levels of control and different levels of production potential. Can range anywhere from $20 per ton to $100 per ton. So knowing what kind of site you have and what your production costs are going to go a long ways into letting you determine whether or not it's going to be economically feasible for you to do any sort of treatment. So there are other alternative ways to try to control pasture weeds, and Walt talked about some of these before. These would fall into what I guess would be considered integrated pest management, and that's basically managing to try to control problem species through other methods to reduce the effect of herbicides and herbicide residues on the environment. And one of those, of course, is birding, which Walt covered some in his earlier talk, and which I alluded to some with honey locust and yucca. But grazing can also be an effective method to try to target some species that are considered to be problems in pasture. So targeted grazing is the term that is often used for trying to directly or indirectly control a species of an undesirable plant in a pasture. And in doing this, in most cases, it's often best to use a high density of animals for a short period of time to get the effect that you want, to try to reduce the population of that problem plant. Now, you can't just go out and graze on these plants anytime and get the effect you want. Basically, what we're trying to do with targeted grazing is we're trying to get that animal to consume or impact the pest or the invasive species the most that it can. And what we're trying to get that animal to do is to reduce the leaf area, to reduce the vigor of those plants, and to try to reduce the ability of that plant to be able to produce buds or produce seeds. So we're not only trying to lower the vigor of the plant as it is growing out in the pasture, but we're also trying to reduce the number of seedlings or propagules for future plants that invasive species could produce. And in order to do that, we need to know our target species as well as possible. For instance, we need to know the anatomy and the physiological differences of, say, controlling yucca versus controlling Japanese brome versus controlling skunk brush in a pasture. All three of those are going to have different time periods of when they should be targeted and are going to be most effective in reaching control. And they're also going to be different in the ideal species that would be used to try to control these. So with yucca plants, using grazing as a control, we'd be grazing in the wintertime, and we'd be grazing with beef cattle. With Japanese brome, we'd be grazing early in the spring, basically from the end of March to sometime in April, when that plant is just starting to put up its seed heads, when it's going into the elongation phase, is when it's going to be impacted the most. And so that's the time period when we'd want to have the most animals on that area to try to control Japanese brome. Whereas with skunk brush, we're going to want to have goats grazing instead of, or goats browsing instead of having cattle trying to be the control mechanism. And we're going to be wanting those animals out there on the skunk brush after it's fully leafed out to reduce as much leaf area as possible on that plant, to reduce its amount of carbohydrate that it's going to be storing and putting into its root system. So knowing the anatomy and physiology and the growth periods of our target plants is key in being able to control them with grazing. And for each plant, it's good to have some sort of prescription grazing plan in order to try to control it. Now, in doing this, we may not always completely eliminate the pest, but in many cases or most cases, we're at least going to be able to suppress it or to slow the spread of that plant. An indirect effect of grazing and controlling invasive plants or undesirable plants in pasture is using what Walt had alluded to earlier, and that is a stocking rate that's going to allow those pastures or those rangelands to be as healthy as possible and have as much vigor as possible. The healthier a stand is, the better it's going to be able to compete with any invading plant and be able to try to ward it off and to be able to withstand competition. So the healthier a rangeland system is, the better it's going to be able to compete and prevent undesirables from trying to come into that area. They offer a high level of resistance. Healthy grass, healthy pasture and rangelands do. So in the end, when trying to control species through grazing, you should know your friends well, but know your enemies even better. You should know when and how your target species is going to be most susceptible and how you're going to be able to most affect it. And with that, that's basically all I have. I guess I say that's all I have, but I've used up quite a bit of time. I'll take any questions if anybody is still on to be able to ask questions.
Yeah, we have some viewers still, and so far none of them have chimed in the chat. I will give them some time to do that. I had a question on, the ragweed side of things. You mentioned way early about you started to say consumed, and then you changed your answer to disappear.
Yes.
I was just curious what your thoughts are on cattle's ability to eat ragweed.
Well, I changed from consumed to disappeared because with continuous stalking, which is basically how that study was performed, it was continuously stalked through the growing season from May through October. The amount of forage that disappears, half of the disappearance is usually from animals consuming the forage, and the other half is from insects consuming the forage, wildlife consuming the forage, or parts of the plant basically sloughing off over time, becoming mature and having plant parts fall off and falling to the ground as litter. And so not everything that disappears is actually consumed. So that's why I changed that. 49% of it disappeared. They didn't actually measure consumption, they measured disappearance. So that's why I changed that.
So to add on to that, are you aware of any studies that cattle do consume ragweed? Because I've heard that it's fairly good quality feed, up to 20-25% crude protein.
I know that they will consume ragweed. I've watched them consume some ragweed. How much, I don't know. You'd have, I guess I don't know of a diet study that specifically looked at ragweed as a species. In eastern Kansas, I know that Walt took part in a study where they were looking at steer diets compared to sheep diets. I don't know if western ragweed was included in that or not, if there was any data on consumption of ragweed in those.
There was, we had 2 or 3 ragweed species. We had common ragweed as well. I can't recall right off the top of my head. That study was primarily, we were interested in whether they're going to consume Sericea lespedeza, but
right.
There was ragweed available in the pasture. And again, I would think that the sheep that were used in that study would consume more ragweed than the steers did.
I would assume that would be the case as well.
Okay. Again, if there's anyone out there that wants to add a question, please feel free to throw that up in the chat. One that we paused on, Sandra typed it in our chat here on the side, and but just so you and maybe Walt and Keith both can expand on this, but what's your opinion on year-round grazing versus conventional grazing and how it relates to weed control? And that's a loaded question. I'm aware of that.
I guess I'm wondering if she means year-round grazing as grazing on the same pasture year-round, or does she mean year-round grazing by rotating from, say, native rangeland to a cool season pasture to, say, a cover crop, or having some sort of year-round forage? Or exactly what do you mean by year-round grazing?
Well, this was brought up in my program development committee for ag, and they just mentioned year-round grazing. So I'm assuming, I may be wrong, I'm assuming the same pasture, because I mean, I was out collecting soil samples, and there's cattle still out on pastures.
Okay.
So I don't know.
And by conventional grazing, I guess maybe they mean continuous grazing through the growing season, just during the growing season.
Right, like typical May to October.
Okay. Well, I guess first off, both of those are going to be methods where animals are going to have highly selective diets. You know, they're going to be able to go out and really select the plants that they want to consume in both cases. At least at the stocking rates they should be stocked at for those long time periods. Those animals should have a lot of selective ability. And I guess I would think that those would possibly end up with almost the same result. Because in year-round grazing on the same pasture year-round, if it was done at the proper stocking rate, you know, those animals out on winter pasture, they would be consuming plant parts that basically are no longer photosynthesizing. So those plants aren't required or relying on that leaf area in order to make it through the winter and to survive. So I guess I would say if it was done at the proper stocking rates for the time periods that are out there, that there might not be much difference between the two. I don't know. Walt can chime in what he thinks.
No, I would agree, Keith. I think, again, it gets back to stocking rate. As long as they aren't abusing the land where they're taking off or causing a lot of disturbance to the soil surface, I don't think we'd see a whole lot of difference. You know, sometimes people will reserve a pasture and just use it during the winter time. And that can be done. And we know that that's not going to be harmful at all. Again, it goes back to, because we aren't hurting the carbohydrate storage and stuff. What the impact that could have is as you remove foliage during the winter time, you don't have the ability to capture maybe snowfall, you know, so you might affect your water cycle more than anything else. But it won't damage the vigor of the plants you can remove a higher percentage of it during the winter time, in other words, than you can during the growing season and not hurt it. Now, what effect that could have on the weeds and stuff, I think it depends on the level of, if there's actually disturbance there that'll allow those plants maybe to come in.
Okay, appreciate the answer on that, guys. We do have a question in the chat here. I believe this could be either one, but I think it's aimed towards Keith. In environmentally sensitive areas, what cut stump treatment would you use on locust trees?
In environmentally sensitive areas, aminopyrrolid is probably going to be the safest treatment. One thing I didn't talk about was picloram. Picloram, or Tordon 22K, has a supplemental label available on the CDMS labels website online that can be downloaded. And that supplemental label states that picloram, or Tordon 22K, can be used with the same basal bark and stump mixtures as aminopyrrolid. So it can be used in grazed pasture now, whereas before that label wasn't available. And those two herbicides, I think, are the two most active herbicides on honey locusts. And out of those two, aminopyrrolid, I think, is by far the more safe herbicide, especially for sensitive areas. It is not translocated as well through the soil. And in the area where I did this study, the stump and bark treatment study, there were other trees in that area. It was a riparian area that probably had a higher water table than most areas in the surrounding region. And we had elm trees, we had some willow trees, we had cedar trees, all in this area. And none of those were affected by the aminopyrrolid treatment. And aminopyrrolid is supposed to be able to be applied right up to water's edge, according to the label.
Hey Keith, this is Clinton, but would you be able to share kind of some of the more common names of those herbicides that you were mentioning?
Yeah, the triclopyr, a common name is Remedy products. And then the aminopyrrolid is Milestone. Okay, those are the two, I guess, that I probably used the most that were just herbicide names and chemical names and not the actual herbicide. The triclopyr is Remedy and aminopyrrolid is Milestone.
Thank you.
All right, thank you for that answer. And I just at that before we go on to the next question we have, but I just want to mention each extension office will have these available. The chemical weed control books available. They come out every year. So stop by your extension office and get a copy of that, and it'll help you out a lot with any of your chemical questions. The next question comes talking about, it's a different species we haven't mentioned today, but actually a couple species, Old World Blue Stem. I know both of you have done a little bit of research on that, but it's referring a question specifically about arsenal and how it works on Old World Blue Stem.
But I guess, Walt, I'll let you start on that one, and then I'll add later.
I think we pretty well agree that on the two herbicides that seem to work are arsenal, which is imazapyr, or glyphosate, Roundup products. Those are the two chemicals we found that work the best on Old World Blue Stem at this time. The advantage that I've seen with the arsenal at let's say that a half-pound rate is that it's fairly safe to use on native grass. It's pretty selective on the Old World Blue Stem and not damage the native grass as much, so it has that advantage. Year in, year out, where we've been comparing maybe a half pound of arsenal with 2 pounds of a glyphosate product. Probably over most years, the glyphosate's probably a little more effective, unless it's dry. When it gets dry, 2 pounds is not as effective as that half-pound rate. And that probably, I think it has to do with residual activity. The arsenal will stay in the system for a while, whereas glyphosate doesn't have any soil activity. So I think that's a key difference.
And I guess I'll add on to that by talking about an area in Ellsworth County that I've been evaluating for the past couple years. But there's a producer that has a large acreage there that they applied arsenal for 3 years in a row at a half-pound rate to a stand that had Old World Blue Stem in it, Caucasian Old World Blue Stem. The stand started out at 51% cover Old World Blue Stem before they started to apply the arsenal. And after 3 years of arsenal treatment, that pasture is down to under 2% cover. So they have had a significant decline in Old World Blue Stem cover from the arsenal treatment. You can imagine going from 51% cover to 2% cover, that's a lot of vegetation missing. And what ended up taking the place of Old World Blue Stem that area was pretty much dominated by Western Ragweed and Mare's Tail. I should say at the start of treatment that native tall grasses in this pasture had a cover of about 10%, and those increased to the mid to upper 20s as far as percent cover combined all together. So there was a significant reduction of oral blue stem and a significant increase in native grasses, but native grasses aren't going to increase near as quickly as what that oral blue stem disappeared. And so something had to take that place, and what took that place was Western Ragweed and Mare's Tail, which ended up being okay because those plants were serving a purpose. They were holding the soil in place. So even though they weren't necessarily desirable as far as forage is concerned, they were serving a purpose, that they were occupying the area and keeping the soil from moving. Now, after the third year of treatment, this person wanted to or needed to seed with native grasses. And they did that this spring, and they seeded with a mixture of native warm season grasses, and also had some native forbs included in there. And basically, in doing the evaluations, I found that the areas that had the greatest oral blue stem cover prior to treatment were the areas that had the greatest native grass seedling establishment after seeding this spring. So that's good news, because it's been shown that oral blue stem, Caucasian oral blue stem and yellow oral blue stem both have had allelopathic effects on native grasses, where it's reduced native grass growth and basically has prevented seedling growth from occurring in a greenhouse and lab setting. So seeing these native grasses established in an area that was so highly dominated by oral blue stem is actually a good sign that we can go back into those areas and establish some native grasses after a few years.
All righty, I will give just a couple more minutes for any questions to come on in. I haven't seen any others, but I do want to mention we do have an evaluation for this program that we would appreciate if you would fill out at the end. It will be in the description in the link. And again, I will let Justine wrap us up here.
Sorry, I had to unmute myself. Okay, as Brett said, there's an evaluation here for you guys, and I just want to kind of take a moment to express how important this is to us as agents. The entire evaluation should really only take less than 5 minutes to fill out, and it can honestly make a world of a difference to us as agents in our future programming. With everything going on, it's kind of difficult for us to connect with you guys and have a conversation after a program about what you thought or what you'd like to see in the future. So we really depend a lot on these evaluations to get a feel for what you guys think, and also help us succeed in delivering educational programs that are really beneficial to your lives and your operation. So if you could just take a moment to fill that out, that is in the chat box, and that will also be linked in the YouTube description when this is posted later to our websites in the YouTube channel. It'll be in that description. So if you are watching this video at a later date, you can also fill that out. Which brings me to my next point. This whole entire program and presentations are recorded. So if you missed the presentations or you want to go back and re-watch them, they will be available on each one of the extension websites, and as well as some of the YouTubes. So you can definitely go back and watch those as well. Alrighty.
One more topic. If you want copies of the presentations of any of the speakers, those will also be posted on all of our district websites. So, or just contact your extension agent and they'd be able to get that for you. Any other questions? Okay, again, thanks for participating, and please watch all of our websites, district websites. There will be future meetings coming up, and actually there's one next week, and I might want to push that one too. It's our cattle marketing and tax program. It is in the evening. It will be December 15th. It starts at 7 p.m. There is a registration site up as well. So all of our extension districts have that link where you can register for that as well. So there'll be other programs coming up too after the first of the year. And unfortunately, according to the pandemic, we'll probably be doing lots of virtual programs here in the near future. So ideally, we'd like to see you each face-to-face, but we cannot do that. And for safety reasons, at least we still want to connect with you and engage with you and provide the information from K-State Research and Extension. So with that, do any of the other agents have anything, or the speakers? Okay, again, have a nice evening and wish you Merry Christmas, and we'll see you next Tuesday evening for the Cattle Marketing and Tax Program. Thanks again.